Hi, in this video, I'll discuss about a number of frequently asked questions in the forecasting. Okay, so one of the basic questions that is often asked in interviews is what are the different ways of doing forecasting? Now, some of the you know most some of the most popular forecasting techniques are the time series forecasting. So whenever we talk about forecasting, most of the times we relate it to the time series forecasting. But other than the time series forecasting, we also have the other kinds of multivariate forecasting techniques which are as good as time series forecasting and are very useful in certain scenarios. So we'll discuss the different the different types of uh, forecast. Okay, so we'll discuss types of different types of forecasting. So the first type is the univariate time series forecasting, which is the most popular one. In the univariate time series forecasting, you'll have the data as per the time period. So this is T1, T2, T3, and so on. And then you have, let's say, the stock price. Okay, so stock price could be something like that. So it goes up and or it goes down, right? Something like that. So it's only so in univariate time series forecasting we only try to or we only take a single variable, okay, the variable of interest, and we see the trend of that variable or how the variable is changing over time. So if it's stock pricing, it could go up and go down or and then go up and something like that. So we only take care of the price of the stock and how it is changing over time, right? We do not see any other variable or any other factor or attribute other than the stock price, right? That's why it's known as univariate. That means only a single variable or um, only one variable that is taken. Okay, so we use a number of techniques to do univariate time series forecasting. You can use simple mathematical techniques like exponential smoothing, okay, or a little more complicated statistical techniques like the AR, the moving average, the um, ARIMA, autoregressive integrated moving average, ARIMA models. So that's about the univariate time series. You can also do forecasting using regression methods or using multivariate techniques. So how do you do that? Well, you can also in cases where your data is only for a single year, okay, say for example you have sales data, okay, and you have it for say 2010. So the date, the year is 2010, and you have several variables, okay. You have say the average income of the customer, then you have uh, uh, say demographic data like population, age, gender distribution, and so on. And you also have the sales data, okay. So sales data is the or the sales figure is the variable of interest for which we want forecasting, but we also have other variable, other attributes which normally impact sales. So in that case we can do the multivariate regression to do forecasting. And remember, if you have data for multiple years, say for example you have data for 2010, you have also data for 2011, 12, and so on, then in that case you have to be a little more careful, and we'll talk about it when you have multiple year data, as well as you have multiple variables in place. But if you have only single year data with multiple variables, then you can always go for regression based model. And then the next one is you can combine time series and the multivariate regressions, and that's what I was talking here. So when you have a number of attributes, okay, you have number of variables in place, and at the same time you have data for a number of years as well, okay. So you have cross section as well as the time series. You have cross section, say, you have a number of variables, could be the customer data, the demographic data, like population, age, and all that. And also you have data for 2010, 2011, 2012. So this is your cross section, and this is your time series, right? So you can combine both time series and multivariate regression, um, and come up with a better forecast. You can also use even more complicated and more accurate data, which is known as the panel data regression for forecasting. I'll not get into the details of panel data regression over here, but yes, you can use uh, you know this type of data as well for forecasting purpose. Another question which is often asked is, how is short-term forecasting different from the long-term forecasting? Well, in the literature, there is this is a controversy. There is no standard way of deciding what is a long-term and what is a short-term forecast. But when you're going for a very immediate, you want to know something happening immediately. Um, it could be a couple of days, couple of weeks, or couple of months. Then we call it a short-term forecast. But when it is like um, given to the frequency. So for example, if it's a daily data, and then you are forecasting for next 12 days, then it's a short-term forecast. And then if it is a daily data, the data is daily, the frequency is daily, and then you are forecasting for, say, how the series look like, that it is, say, 3 months from now, 3 months from today, then it considers a long-term forecast. Well, there is no threshold, there is no definition as such, but yes, depending on the problem at hand, you can decide what is short-term and what is long-term. Well, it. So how are they different? They're different in a variety of ways. The variables or the attributes or the factors which impact your variable of interest could be drastically different when you take short-term and long-term forecasting. Say, for example, you are doing forecasting in a consumer market. Okay, an e-commerce company is selling something, and you are trying to forecast its sales. Now, if it is a holiday season, if it's a holiday season and there is discount, so you can use that. So discount or promotion is one of the factor which can be used for short-term forecast, right? Forecast. Now, if you want to forecast for long-term, so how is the sale going to be? 6 months from now or 6 months from today, you cannot use discount at this point in time. Instead, you have to use variables like the economic scenario, the macroeconomic scenario, the macro scenario of the country. Okay, or maybe the average income, or you can take any other proxy variables like the oil price, gold price, or any index, stock index for that matter, as the macroeconomic variable uh, for long-term forecasting. Secondly, the bucketing also is important thing. That means in the short-term forecast, you probably need to do the forecasting for next couple of periods. So if you have like daily data, you probably will be interested in next forecasting for next 3 days or 6 days or 12 days or so on. Uh, on the other hand, when you're doing a long-term forecast, you probably would like to take the monthly bucketing. So this is first month, this is second month, third month, and then you do it for another 6 months or 12 months. Similarly, if it is similarly, that's the way you do, because if you take daily data series and want to do forecasting for next 6 months, it's not the right way to do. Instead, you should take the monthly data and do the do the forecasting. So you can actually convert this daily data into monthly data and do the forecasting. And you can also so you can combine this data and make it as monthly data and then do the long-term forecasting. That also you can also try out for better accuracy. And also the duration of data is some people say it does matter. So if you are doing long-term forecasting, the length of data that for which you have that you have taken for forecasting should be fairly long when it comes to long-term forecasting. On the other hand, if it is short-term forecasting, a shorter duration data is also okay. So if it is long-term, so you should take longer duration data. And why it is so? Because when you're doing long-term forecasting, you will come across a number of random shocks, number of cases where you will have seasonality, random shocks, and all that. So all that will be captured only when you take a longer duration data for analysis purpose. So that's important. On the other hand, when you do short-term forecasting, you do not need to keep data for something which comes extremely randomly in the series, or something that is totally happening in a different period. You should take only the nearby data, right? A smaller data is good enough for forecasting in that case. Another question that is often asked is in interviews is how do you validate forecasting model? Okay, so you can do validation in a number of ways. Of course, depends on what kind of forecasting model you are building. But some of the commonly used for validation techniques are the out of sample validations, wherein you take the training sample, you do your forecasting. Say this is your training sample, where you have taken data from 0 to 80th period, and then you are keeping the 80th period to the 100th period as the validation sample. Okay, so or the holdout sample. Holdout. You do not use this much data for your model building purpose. You only use this 80% data, and then you test your data in the rest 20% or 30%, and then you see whether the forecasting error is consistent. Okay, forecast error is consistent. That means is it also giving that kind of forecast, or it's deviating seriously from that, right? This is called out of sample. That means, and this is in time series, and in the multivariate regression, uh, you can simply take you can randomly take 70% or 80% of the data, do the modeling, and rest 30% or 20% for holdout. Okay, another type of validation is known as the out time validation. Okay, now many times you will do forecasting for a given year. So you took data for 2010 and you built a model, forecasting model, but you probably want to test this model if it works in other years as well. So you took data for 2011 or 2009 and test your results over the other periods. So the period that you haven't taken in the model building or in the training sample. Okay, that's known as the out time validations. So in time series, your out time and your hold, your out of sample validation is pretty same. If you go back in time series, this is also out time validation because we did not take for this period, right? So for univariate time series, they are all they're both the same, but when it comes to the multivariate models, the out time and the out sample validations are different and should be performed differently. Other way of validating a model is cross validations. So when you do out time and out sample validation, you only take one or two data and do a validation, right? But what is the guarantee that it's going to work in all samples? So in cross validation, you take multiple samples. Okay, it could be 10 samples, or it could be 100 samples also. So you 1,000 samples, something like that, or many more samples, right? You randomly choose samples from your data and then test your model if it is working fine. You can also do what is known as a stress testing. Stress testing, which is very popular technique in the financial service industry, in the financial service, the banking industry. This is one of the regulatory, uh, you know, uh, which comes under the regulatory framework where forecasting model has to be stress test. And what does that mean? So what we mean by stress testing is that whether your forecasting model is actually performing well in stressed scenario, right? In extreme economic bad conditions, right? For example, it could be a recession or a stock market crash, or it could be a bubble, right? It like the dot-com bubble, right? So these are some of the extreme situations in which your forecasting model should be able to give you some sort of indication of something bad happening. So so you create scenarios, different scenarios, and test your model. So you create different scenarios, right? If what if one of the factor goes off, how your testing your forecast really get affected. So you artificially increase your values for one of the factor and see what is its impact in the forecasting model and whether it's accurate given the historical situations. So we'll not get into the details of stress testing. You will have another video on stress testing. So this is you can read it out on the Wikipedia what stress testing is, and you can get to know more about it, which is an important thing in the banking and financial service industry. Okay, another question which is often asked is how is seasonality? How does seasonality affect your forecast? So let me tell you first what seasonality is. Well, seasonality is a case where or a situation where your the variable of interest for which you want to do forecasting, it has an extreme value at that particular point in time. So for example, the popular theme that is that always show seasonality is your sales of most of the consumer goods in the month of December, right? So we'll have December. So your sales will have a constant value, and in the December it goes up. Then constant value, it goes up, and so on. Because in December it's a holiday season, right? Because of Christmas. So because of Christmas and holiday, New Year, normally people buy more, right? And they spend more on buying consumer products. That's why your sales figure will have highest peaks during the time of December and the year end, right? So this thing, this is known as seasonality, right? So it could be yearly seasonality, it could be monthly seasonality, it could be quarterly seasonality, right? That means a jump is happening at an equal interval of time at a specific period, right? At a particular period, it is happening, and it is happening regularly, right? It's happening in December 2011 to 2012, 13, 14. So every year in December you have a jump, and that's known as seasonality. So how does it impact your forecast? Well, when you're doing a forecasting or building a forecasting model, you should ensure that while when you apply the technique, your seasonal variables are deseasonalized, or you should ensure that it is normal. And then when you build the model, so you can actually ensure that the seasonality is well taken care of when you actually uh, you know um, smooth it, and then again ensure that the seasonal factors are taken care of in the model. So I'll not get into the details of how seasonalities are taken into consideration in the time series model, because that's a little more complicated and I do not have the time in this particular video to get into details. But I can talk about how seasonality is taken care in multivariate models. In multivariate model, you can actually use a dummy variable, okay, in a dummy variable for a particular month or particular week for which you are finding seasonality. So it could be like, so for example, in the case of sales forecasting. For December, we can have 1 and 0 case. So if the month is December, then we create a dummy variable which takes a value of 1. Otherwise, it takes value of 0, right? So we can have this dummy variable and use that in the regression, and this will capture the additional sales that is happening in the month of December. So which will get added to the overall forecast. So that's the way you do it.